Everybody, it's Mrs. Dinkelman, and these are the notes for the Riemann sums, really the part one. I know it says 4.3 here, but we're just kind of using some different things than Gary's curriculum. So hopefully you have this printed out. If not, hit pause and make sure you have this, or write notes yourself. I will have some printouts for those who are in class. I will try to get to those to you as soon as possible. So one of the things we're going to find out eventually is that when we find the integral, it will actually help us find the area under a curve. This particular curve is a piecewise function, and luckily they're all lines and circles, so we should be able to find the area under the curve just using kind of our arithmetic skills from when we learned about areas. So let's kind of do this in pieces. So for this triangle, it's a 1 by 2 divided by 2, so that area is 1. I'm just going to write it in there. For this square, 2 by 2. For trapezoids, there's a couple ways to do it, but we are going to have to know trapezoids for the next part of this unit, so I'm just going to remind you what the area of the trapezoid is, and that would be base 1 plus base 2 divided by 2 times the height. So in this particular case, base 1 and base 2 are 1 and 2. It doesn't really matter which is which. And then the height, because this guy's kind of on his side, is 1, and so we're going to get 3 halves for that. And then we have this square that's 1 by 1, and then we have a quarter of a circle. So pi r squared, r is 1, and then divided by 4. So we could kind of add those up. So 6, 7.5 plus pi over 4. Okay, but when it's a curve, we can't really do that. So we're at first going to start by just trying to estimate what the area would be by using rectangles, and the next part we will do trapezoids because those can be generally a little bit more accurate, and then we'll try to be perfectly accurate. Okay, so a left Riemann sum, what that means, and Riemann was a mathematician who has, he did a lot of things for mathematics, but in this case, we're going to use his rectangles, and I don't know why all of that is cut off, but we'll figure that out. So the left Riemann sum, what that means is when we look at the 2 points that we could use to create the rectangle, we pick the point that's on the left of the x coordinates, and we use that to draw the rectangle. So again, if I'm looking at these 2 x coordinates, I pick the one on the left to draw the rectangle, and maybe it would be easier if I just started with a random curve. Okay, so if I'm going to draw a rectangle between these 2 locations, I'm going to pick the y coordinate from the left and use that to draw a rectangle. And then I would just keep going down the line and find all of those rectangles. Okay, so that's what we're going to start with, is just finding those. And then the right Riemann sum, instead of picking the point on the left, we're going to pick the point on the right. So let's kind of put that into action. Again, the more rectangles we use, the better off it's going to be. They don't technically have to be the same width like this first picture, but for us it's easier to calculate the area if they're all the same width. So we will tend to have them all the same width. And to kind of just talk a little bit about how this is going to relate to the integral, that is that little dx that's at the end of the integral is really like that delta x, that's the width of each rectangle. And the function is the height of the rectangle. So what we're going to be doing is doing a lot of delta x's times f of x's, or widths times heights, or base times height, and we'll kind of see that as we go. Really quick, we're not going to have to deal with this too much, but technically an integral is a limit. If you remember me saying at the beginning of the year, it's not really calculus unless we're doing the limit. And so that limit, n approaches infinity, that's saying that the number of rectangles we're going to use under the curve is going to be infinite. And so then if we could do an infinite number of rectangles, we would get the exact area under the curve. Okay, so for this example, use the left and right Riemann sum to approximate. We're going to go the area from 0 to 1. We're going to use 4 intervals, and we're probably going to need to get our calculator out for this. So we can actually draw the pictures if we want. So we want to do 4 rectangles, and we're doing, let's do the left first. So I'm just going to drag this up, but we're using the left-hand side for the y coordinates. It's going to be a little bit above. That was a terrible drawing. Let's try that again. We're going to do the left to draw the rectangle, And this next one, we would use the left to draw the rectangle, and so on. And if it's helpful for you to draw the rectangle, please do so. I'm not sure how helpful my drawing is. It's not so great. But let's talk about what the intervals are. So if I have to go from 0 to 1 and use 4, then I think my delta x, or the width of each of these rectangles, is going to be 0.25. Most of the time we can just mathematically figure that out, but what we can do is take those two numbers, 0 to 1, and divide it by the number of rectangles we're going to use. So my brain likes to write out what those intervals are. So 0 to 0.25, and then 0.25 to 0.5. Okay, that would really be my second rectangle. Third rectangle is going to go from 0.5 to 0.75, and then finally 0.75 to 1. Now we can actually use these intervals for both since we're doing a left and a right. So for this first example, we're going to pick the x's on the left. Okay, we know that the width of each one of these rectangles is 0.25. Okay, and then we're going to find the height. And I'm going to give you, I'm going to write it out long this time, but if you want to wait and see how we could do a shortcut, you can certainly do that. Now the way I'm going to find the height of this first rectangle is I'm going to have to figure out what f of 0 is. So I'm just going to call it f of 0 for now. I know I can figure that one out, but I'm going to jump to my calculator here in a second. Second rectangle also has a width of 0.25. The way I'm going to figure out how tall that one is, or the height of that one, is I'm going to use the x value 0.25. Again, I underlined it here so that I would know that's how I'm going to find my height. But I'm going to have to use my calculator for that, although it wouldn't be terrible. I just don't want to do that much work. Third rectangle. Okay, still a height of, or still a width of 0.25. The height, I'm going to have to use the x-coordinate 0.5 to find how tall it is. And then finally, the last one, I'm going to use 0.75 to plug in. Okay, so here's the shortcut. Since they're all going by 0.25s, I could factor that out and then multiply the heights each time, which is what I think I will do on the calculator. Okay, so we're going to continue to add all of the y coordinates here. And like I said, I'm going to get out my calculator and I'm going to do this on the calculator. Looks like a lot of mess. Okay. Okay, so let me show you one of the ways on the 89 that I like to do this. I like to go ahead and put the function in the y1 so I don't have to continually type the function over and over again. So it's negative x squared plus 2. Okay. You can also do this on the 84. It's just that when you type in y1, you actually have to go to vars to find the y1. So again, I factored out that 0.25 because I knew I was going to use it over and over again. So I'm going to do that on the calculator. And then instead of f of 0, etc., on the calculator, I have to type y1 of 0. And then the next one is y1 of 0.25. And then y1 of 0.5, and then y1 of 0.75. Let me just look back at that and make sure that looks right. Oh, looks like I didn't type y1 there, so let me fix that. Okay, let's try again. Okay, so 1.781. Remember, we go to 3 decimal places for the AP exam. 1.781. Okay, for this example 2, I'm going to use the right Riemann sum. So I'm going to come back over here and say, okay, I'm going to pick the right x-coordinate from each of those intervals that I used down here. So it's going to be really similar. I know that each of the widths is going to be 0.25, but this time I'm going to need f of, instead of 0, I'm going to pick 0.25, and then 0.5, and 0.75, and then 1. Okay, so back at my calculator, I'm going to cheat a little bit, and oops, I'm going to add in here that I want y1 of 1, And I'm going to go ahead and delete, if it will let me, that y1 of 0 that I had at the beginning. Now I think based on the picture that that first one was an overestimate and that this second one is then probably going to be an underestimate. I didn't draw the picture, but that's what I'm going to bet. Oops. I think it made me delete the whole thing. Okay, let's try this again. Okay, so again, let's put in y1 of 1. And then maybe a plus sign would be good. And then delete. Okay, let's see if that works. So 1.531. I feel pretty confident about those two answers. They seem fairly close together. And like I said, I expected this one to be a little bit lower. Okay, so sometimes they give us a table of values instead, and we don't have the curve and we still have to find the Riemann sum. Now this is going to be a case where the widths of every rectangle are not the same. So let's do the left Riemann sum first. What I like to do is kind of parse out that there are definitely going to be 4 rectangles here, and for this first, for the left Riemann sum, I'm going to need these y coordinates. Okay, so for this first rectangle, it's going to be a 2 by 0 because I'm picking the left, right? And then for the second one, it's going to be a 3 by 4. For the third one, the distance between the x's is a 2, and again, I picked the left 13. And then the last one is a 1 by 21. So let's see, that's 0, 12, 26, 21, and so 59. Double check me. Okay, so let's do the right Riemann sum. So this time, I'm going to pick the y coordinates on the right. Okay, so first one, still with the 2, but this time I'm going to pick the 4. Second rectangle, 3 by 13. Third rectangle, 2 by 21. And the last rectangle is that 1 by 23. This one seems like it's going to be quite a bit bigger. So 8 plus 39 plus 42 plus 23. Let's see, so 50, 89, I need to write that down. Yes, plus 23. You guys check my arithmetic on this. So 112. Okay, we're also going to talk about the midpoint. So we've done the left, we've done the right. The midpoint is really similar. It's just that instead of picking the x-coordinate on the left and the x-coordinate on the right, we have to pick the middle of them. Okay, so I'm going to look at my interval for rectangles here. And so I am going to go by halves here. So 0 to 1/2, 1/2 to 1, 1 to 1.5, and then 1.5 to 2. Those are my 4 rectangles. And then I'm going to write the midpoint. So in between 0 and 1/2 would be 0.25, and then 0.75, 1.25, and then 1.75. So that's going to be the x coordinates I need that will help me find the height of each of those. Now the width of each of these is 1/2, as I mentioned before. So I'm going to go ahead and put the 1/2 on the outside right now, and then write down what I'm going to do in my calculator. I'm going to have to figure out what f of 0.25 is. That will be the height of the first one, and then 0.75 for the second one, 1.25 for the third one, 1.75 for the fourth one. So we'll go to our calculator again. And like I said, the trick I like to use so I don't have to keep plugging that in is to go ahead and change my y equals maybe. So this is x squared plus 1. And then let me go back to my home screen. So again, I'm doing 0.5 as each of the widths, and then I need y1 of 0.25, y1 of 0.75, y1 of 1.25, and then y1 of 1.75. Okay, so 4.625 looks like the answer. Okay, and then again with a table. So we have to do 3, and they always have to kind of give us extra stuff here, otherwise we couldn't do the midpoint. So I have to pick the middle y coordinate here. And the width of each of these, at least in this particular table, is the same. It's always going by 2s if we're trying to get those 3 equal partitions. So I'm going to go ahead and factor the 2 out, since I know each of them is going to be a width of 2. And then I'll take the y coordinates that are in the middle, and we'll figure out what that is. So let's see, this is 13 plus 19, which would be 32. So 64 for that one. Okay, so we are going to save trapezoidal sums for part 2. If you want to watch it right now, you can, but I'm going to make it a separate video. And some of you will get the notes in class instead. Okay, good luck. I would try that. The first part, it's 6 point, let me look. This assignment is from our packet, even though the notes aren't really. I just want to make sure. So it's 6.7, I believe, 1 through 9. That's what I would kind of work on here, although the midpoint might actually be on the 6.9, but that's okay.